Today is access control list. You see, we are going to control the access by writing list of permit and deny statement. We are going to write list of permit and deny statement. That list will be referred by the routers before allowing a traffic, before allowing packets to go to the destination. Routers will refer to this list, and if the list says permit, only then the packet will be permitted. You see, it is controlling the flow of traffic, controlling the access to the networks, devices. That is why we call it as access control list. List of permits and deny statements, which will be referred by the routers before forwarding to some destinations like a server or a computer or a network or another router. And if the statements have got permit on it, it's going to allow. If it has got deny for the destination, then it is going to stop. By default, routers, they don't care if they have the route to the destination, they will forward. Now we are going to make the router to act as a firewall by writing this list. Only firewall used to do this type of inspection. Who is going? Where is going? Why is going? Who will do this? Not the router. Firewall will do. Now we make the router to be the RTO office. You know, RTO office. The RTO officer only has got the rights to check your license, your RC book, when you're on the roadside. The traffic police job is like a router, allowing the traffic to flow. But it is the RTO office job to check for your insurance, license, etc. Now, by writing an ACL, access control list, I make the traffic police to be also a RTO. Yeah. By writing an access control list, the routers get the additional feature to do inspection based on the destination. It decides whether to permit or deny. Even when there is route, it will deny because the access control list says don't send. Even though there is route in the routing table, because your routing table because your access list say don't allow, it won't allow, it will stop. So here we see, without you buying a buying a firewall, your router is doing the job of firewall. That doesn't mean that you should not buy a firewall. Firewalls can do a lot of big stuff which a router cannot do. This is basic firewall. ACL, access control list, as a basic firewall function. Routers now start functioning like a firewall, but not all the features of a firewall, just this feature, whether to permit or deny based on the destination to which the packet goes. Now, this access control list is of two types. Number one, the decision whether to permit or deny is only based on the source address. If it is so, then you call it as standard access list. Standard access list. Standard access list, I made a mistake. No problem in doing like this. See, there is also another category, okay, but which is not important. This is what I'm saying is what important. Access list is also having another two category. One is named access list and numbered access list. That is nothing but identifying an access list with a number, identifying an access list with a name. But I don't want to call this as two different types of access list. So what we are talking here is the right way. Access list, I have a standard access list, which is only focusing on from where the traffic is coming, based on which it is going to decide whether to permit or deny. It is standard access list. There is extended access list, which is going to now check protocol, source, destination, and optionally service. If you want to match these three, optionally you can also include this. So if you want to match a traffic with all these four things or three things before deciding whether to permit or deny, you want to match which protocol packet it is, from where it is coming, to where it is going, what exact service. If you want to see all these after which you want to decide, then you need to write extended access list. This is the actual two type of access list, okay, standard and extended. And this standard and extended access list, you can identify with a number, then it is called numbered access list. If you identify the standard or extended access list with a name, then it is called named access list. So I don't want to call this as two type of access list. This is two way of identifying access list. These are the actual two types of access list. Actual two types of access list. This is two ways of identifying the access list. This named is both for standard as well as extended. Number is also both for standard and extended. Are you clear with this part, name number? Saravana? Right, then I'm going to remove this. This will come later. So let us focus on the important types only. Standard access list will see from which computer the traffic is coming. And then the decision is made. Whereas extended access list C, from which computer it is coming, to which destination computer it is going, what protocol it is using. By seeing all this, it will decide. So it's all depending on what do you want, whether to go for standard or extended is determined. What do you want? Do you want to only match the source? Then worry not. Just go with standard access list. But if you want to have anything more than that, you may be willing to match the protocol and the destination, let's say. Then you have to go with this extended access list. If you want to use anything other than or anything more than standard access, more than source, then you need to use extended access list. Only the source I want, then you don't need to think about extended access list. You want source plus something, then you need extended access list. Sometimes you may not be worried about source. You want to focus on the destination and the protocol. Even then, you have extended access list. Other than source, anything else you want to add, you need extended access list. All right. Let's see an example now. I have a computer here with IP address 10001. Another computer here, 10002. And I have a router with 20001 connected to the router 20002. And on this interface, you got IP address 10003. On this interface, you got IP address 20003. Now you see by default, there is no one stopping this A talking to C or D. A can talk to C, A can talk to D, C can talk to B, D can talk to B. No one can stop because there is a route in the routing table saying 10 is connected on F00, 20 is connected on F01. There is a route. They're going to talk. But I do not want this particular computer talking to anyone on the right. I don't want the traffic with a source address 10.0.0.1. I don't want this traffic coming from 10.0.0.1 talking to C or D. Look at this. My match criteria is only source. I simply want to say if it is a computer, don't allow. That's it. I don't want to mention about the destination 20001, 200. I don't want to mention those things. I simply want to say if traffic is coming from A 10001, then deny. Then which access list you need? Standard. You need only standard. There is no need for extended in this case. But if you want to Allow A talking to D, but A talking to C is denied. Then you need extended access list. Why? Because I want to match the destination also. When the destination changes, the policy changes. When the destination is D, I want to say permit. When the destination is C, I want to say deny. So in that case, you will use extended access list. So when A wants to talk to D, router will check and allow. When the same A wants to talk to C, a router won't allow the traffic to go out. The source is same, but the destination, when it differs, the policy changes. This is possible only through extended access list. Standard access list cannot do this because standard access list only see the source. If the source matches, it denies. So it is denying for both the destinations, for all the destinations. Even if you have 1,000 computers here, for all 1,000 it will deny. So when do we need extended access list? Whenever you have the destination to match, you need extended access list. Let me quickly do this small lab first. Now, before I take you to the small lab, I want to tell you how to configure, where to configure. We need to configure on the global configuration mode and then apply it on the interface. For example, to achieve this, let's say first we will do standard access list. I don't want A talking to anyone in this direction. A talking to anyone in this direction not permitted. So I don't care about the destination A. If A matches, this port should not allow. Look at this port. But where do you write the access list? In the global configuration mode. I say access list. And I'm going to use a numbered access list. For standard access list, you will be using number between 1 to 99. Any number you can use between 1 to 99 if you are planning to match only the source. Standard access list, 1 to 99. If you are planning to match more than source, then it is extended access list. It is 100 to 199. So don't forget, the number matters. The number matters. Look at this. If I put 100, the router will wait for you to provide protocol, destination. It won't be accepting. It will not accept only your source. It will say, hey, you said extended, give me the protocol. Give me the destination. If you don't give it, will say incomplete configuration. So when you are writing only the source to match, then make sure you put a number between 1 to 99. I'm going to say 10. Access list 10. Deny. This particular IP, one single IP, it is not the whole network, one single IP. If it is one single IP, then you put the keyword host. Host 10.0.0.1. That's it. Deny this guy. Deny 10.0.0.1. Now you need to go under this interface by typing this command interface F01. Go inside the interface And you go inside the interface and say IP access group 10 out. You see, I'm using the keyword out. In, out. This should not confuse you. When should I use out? You see, when the traffic is about to go out on this port, not in, because you are focusing on this direction, right? Traffic is in this direction. So from the firewall, from the router, when it is going out, you need to take this action. What action? Deny. Will you say in there? No, you should not say in, because traffic is coming from here. It is processing, and when it is about to go out, you want to take this action. You don't want to send out. Okay. So we write in the global mode and we bind it to the interface. When you do that, listen carefully. Traffic is coming from A, wants to go to D. What is the source address? 10.0.0.1. What is the destination address? 20.0.0.2. Traffic comes to the router. Router 1 checks the routing table. Destination is 20. 20 is on which interface? F01. But when it is about to send out on F01, it says go and meet access list 10. It goes and meets access list 10. Their access list says don't allow. It won't be allowed. Did you understand, all of you? If I ping from 10.0.0.2, what is the source? 10.0.0.2. And the destination is 20.0.0.1. What will happen? But I'm denying only this. 10.0.0.1. This is 10.0.0.2. How do you say it will deny? Yeah. Okay. This 10 is not 10 network, my friend. Okay, let me say 1. This is just access list number 1. We have said deny this host 10.0.0.1. But this is not 10.0.0.1. This is 10.0.0.2. You said it will deny earlier. You said it will deny, no? Now you are saying it will permit? Okay. What do you want to say, Sangeeta ma'am? ஐயோ என் கேள்வி அது இல்ல. Oh, it will ping, eh? Okay. Okay. What about you, Murthy sir? Super. That is what we all will think. But what Saravana said is the right answer. In the beginning, Saravana said it won't ping. He said it won't ping. Yes, it won't ping. The answer is what Murthy said. நம்ம தான் எழுதல இல்ல. எழுதாததுக்கு என்ன பண்ணணும்? அப்படியே டிராப் பண்ணிட்டோம். We have not written any information about 10.0.0.2. We said 10.0.0.1 deny, but you did not say anything about 10.0.0.2. For security reason, what this router will do, சொல்லாத வேலையை செய்யக்கூடாது நம்ம. பேசாம என்ன பண்ணிடுவோம், இவனையும் நிறுத்திடுவோம். Let us not send this guy also because nothing told about this guy. Yes, that is what I want to say. When you write an access list, this is your first list, first line in the list. When you write one line, there is another line automatically written, automatically. I repeat the word automatic. You didn't write it. What is that line? Deny any. You didn't write this line, deny any. Deny meaning access list one, deny any. I'm repeating. You did not write this. You have not written this. You haven't written this. It is written implicitly. What? Implicitly means what? Without we writing. தன்னைத்தானே எழுதிக்கோ, அதுவாகவே எழுதிக்கோ. Implicitly it is written. So what we have to do, if I want B to talk, what should I do? You write this line. Now when you write a line, that will be added before this automatic line. When you write a line, that line will go and sit before this dynamically generated line. So what I'm going to do is, okay, I'm going to write, this is already done, first line. I'm going to write another line, access list. One, permit any. I'm going to say permit any, so that other than this, all the rest will be permitted. You need to remember this. Don't simply leave after denying. You have to say what action to be taken for other that you did not match. For all other which I did not match, permit. You have to say this because there is implicit deny at the bottom. What is the word? There is an implicit deny at the bottom. There is an implicit deny at the bottom. To override this implicit deny, you have to say permit any. If you fail to say this, B cannot talk to C and D. If you forget to write this line will be matched. Any other than this, I have to deny. This line is automatic line. This line will be matched. Okay, there is another rule I want to tell you. When a packet is arriving, it will first match with the first line. If the first line don't match, it will match with the next line. If the next line also don't match, it will move to the third line. Listen, I'm picking from 10002. Is it matching with the first line? No, not matched. Is it matching with the second line? Yes. Any 10002, any. I have to permit. It will permit. This line is an automatic line. Implicit deny. When you write something, this will keep going down and down and down. So access list will always read from the top. When a match is found, it won't read the next line. It will not read the next line. If a match is found, it won't read the next line. Here, third line will not be read because there is a match in the second line. Second line says anything you permit. Now, when the packet is coming from A, 10001, it matches on the very first line. Action is taken. It won't read the second line. It will not, because there is already a match. Did you understand, everyone? Hmm. Doubt. Hmm. Very good question. Question is this. We have never done access list lab earlier, and we were able to ping, but now you are saying only when you write this permit any it will ping. No, I did not say like that. Understand this. If you will write access list, only then this line will be implicitly written and all the traffic will be denied. To override that, we write this. If there is no access list, then that rule don't apply. There is no implicit deny. You will be able to ping. Only if you write this first line and if you forget to write the second line, this implicit line which is written dynamically will prevent B talking to C and D. When you first place don't have any access list, there is no implicit deny. There is nothing. If you have root, the ping will happen. You got it? Right. Better.